Then we go to type curve generation. This is a process to assess and quantify the impact and influence of each of the reservoir and design parameters on the well productivity. The key about the type curve, we've all seen type curves in our industry. The key about them is that they always very well behaved. They're graphical representation of theoretical responses and interpretation of models and that represent for a given well or a reservoir, and they always behave so very nicely. Why? Because they are developed based on equations that are solved either analytically or numerically. Now, these are type curves that are developed based on the predictive model that we had based on completely on data and no equation. And the fact that they behave so nicely, the only thing that it can be attributed to is a very well understanding of the physics from the data. So here you will see in several plots, on the x-axis you see the stage length on foot, average stage length from 200 to 700. In x-axis and in y-axis you see best 30-day gas production, which is and then each line identifies through a TVD here, and as you see, as TVD increases, so does the production in this particular one for the entire asset. In this one, the same type curves are for initial shut-in pressure at different values, and this one is for average treatment pressure. The same thing we saw earlier, lower treatment pressure apparently provides higher productivity, and after a while that distance between the lines it decreases and becomes very, very closer. And if we take one of the things we have done, we define these laterals as in a pad as type 1, type 2, and type 3. Type 1 is the one that does not share reservoir with any lateral. Type 2 is side ones that share on one side but does not share on the other. And type 3 is the lateral that share reservoir in both sides. And then you can also, we define during our modeling, we define this inside distance between laterals in a pad, and outside distance, that is that distance between a lateral and an offset pad. And when we do that, we can actually develop type curves to identify, for example, for type 2 laterals in a given BTU area, we can identify what is the best distance between lateral in the same pad in order to get. So as you see here clearly, there is an optimum value for this. If you plot the distance closest to the lateral in x-axis and the cum production in y-axis, and for different distance between the laterals, you can actually identify. Right now we use a cookie cutter approach in most of our work, but the fact is there is an optimum that can be found. And the same thing is true if you go to a distance between lateral in the same pad. Now this shows it for another well. And what this tells you, this is for two different wells. This is one well in one location in the reservoir. This is another well in another location in the reservoir. So in other words, you can find optimum distance between stages for different locations in the reservoir. The next item is, how do we use this to evaluate service companies? Well, this is a process to evaluate quality of the completion performed by service companies using this analysis. In this exercise, we used 4 of the service companies that have performed for this particular asset. And what we do, we want to see what we take, for example, in this plot, you see the net Cherry Valley thickness. Cherry Valley in parts of Marcellus is where they land between Upper Marcellus and Lower Marcellus, and then they extend the lateral, and then you plot that value, the thickness of that versus net Marcellus thickness, and then you will see this data. And if you look at the service company number 1, this is the range that they worked with. Service company number 2 worked with a smaller range, and service number 3 is almost the same as service number 2, but company number 4 actually worked a very, very small range. Well, it's because we worked in the better part or not the good part of the reservoir. So we're trying to compare apple with apple. If this is the entire range they could have worked with, you saw what percent of that they. So if in here it shows you that if you plot net thickness versus Cherry Valley, we have identified these two to be very important. Then service company 1 really used 98% of that range. available range. Service company 2 50 and 3 52, and service company 4 only worked in 4% of that. And then the next item is initial gas in place and TVD. And when you do that, you will see that service company 1, service company 2, service company 3, and service company 4. And if you put them all together versus what's available to them, you will see that the range at which each one used it is 74, 52, 34. And there is one last one, and that is surface latitude versus operational constraint, which is best 30 days casing pressure. And again, the ranges for each service company are identified here. And we want to know, or actually we want to normalize the quality of the work they done based on what was available to them, or in other words, based on the ranges that they work with. And here you see from 80 to 21. You take these and then you put them together and you come up with a average of 84% of all these 6 parameters that they have identified are very important. Of that service company 1 to 4, this is the range they have dealt with. Then here, what we have done is we show that blue shows original well quality, and red shows improvement. So if you look at service company 1, they had they were dealing with reasonably good portion of the reservoir, and the improvement they made was not that much. On look-back analysis. Service company 2, they work with a part of the reservoir that had very good or reasonably good quality, and what they were not able to improve anything beyond what it was. Service company number 3 actually had a good portion of the part of the reservoir, but they were not able to actually improve beyond what they could have done, while service company number 4 was able to improve what they had done very much. But if you look at it, this plot tells you the range that they were covered. So this guy's covered at a higher range. These 2 guys covered almost the same range, although these guys, number 4, did very good job, but they were only tested at a small portion. So if you take all that and put together, you will find service company number 4 get a better overall performance matrix compared to 2, 1, and 3.